Now we are looking at the chapter 2 question and answer of Dr. Rajiv Mal book of software engineering. So first is, what do you understand by the term life cycle model of software development? So the chapter was software life cycle models. We have learned about software models, various software models. So what do you understand by the term this life cycle model, and why is it important to adhere to a life cycle model during development of a large software product? So when we're discussing the chapter, we tried to answer this question, but we'll formally answer this, that life cycle model of software development, it actually refers to the development of software through a sequence of activities structured into the phases of a life cycle model. So what it says is there has to be an engineering approach to make a software. So when you apply this life cycle model, there are different phases, and these phases are well defined, well managed, and well planned. About the second part, why it is important to adhere to a life cycle model during development of large software product. Just as we said that there was software crisis, and just because of that, things came into being. So it is always important, advisable to follow a life cycle model in product development, developing by just a team of professionals, since we want that this life cycle model, if they're adopted, if it is not adopted, it will be very difficult to develop the product. Why? First of all, it gives you an idea of what is to be done, when is to be done, where is to be done, and why it is to be done. Right from the initial phase, from feasibility study till the maintenance phase, each thing or each aspect is predefined. And as far as project manager is concerned, he will have the exact idea about the schedule of the project. He will see that the project is not going to overrun with respect to the cost or the schedule. Now the second is, let me just suggest one thing, that these are the answers which are being given by or written by Dr. Rajiv Mal itself. I'm just adding my view and ideas which I've learned in the course of studies. The second question is, what problems is a software development organization likely to face if it has not adequately documented its software process? So if the documentation is not proper, what may be the problems? First of all, if it is not documented, you will not be able to understand and maintain the software. And when you will run into some difficulty, or any developer will find himself in some difficulty, there is nothing to refer. And a good quality document, if it is made, then it acts as a milestone when it is properly reviewed, being seen by yourself, the team, and the end user. So to track the progress, to know what we are doing is correct or not, verified or validated, we really need documented software process. Then the third question in this chapter is, what do you mean by software process? This is a very important question, certainly asked in various interviews. So what do you mean by software process, and what is the difference between a methodology and a process? So there is a clean distinction between methodology and a process. And what problems would a software development house face if it does not follow any process in its software development efforts? So we'll try to answer first part, that is, what is software process? The software development process or software process, it actually tells you or defines the order in which different development activities are carried out by your team or the software team, development team, while the methodology is something different, which spans a single phase of development, whereas process spans the entire life cycle. Process is right from the inception to the maintenance, while the methodology, it spans for a single phase of life cycle. Let us answer the second part. So if a software development house does not follow any process, what is going to be the result? it may happen the development efforts may end up in failures. The cost would be higher to develop the software, and the management of the software in terms of time and cost will result in schedule slippages. Fourth is what or which are the major phases in waterfall model or software development, and which phase consumes the maximum effort for developing a typical software product. This is a question which is because if you have heard or learned the book of Dr. Rajib, he has given a clear distinction between waterfall model, and there are two types of waterfall model. That is, one is classical, then we have iterative. So what are the major phases? Because the phases remains the same in these two waterfall model. So the phases of this waterfall model is, first is our feasibility study, then we have requirement analysis and specification, then comes the design followed by coding, and then unit testing, integration and system testing, and finally the maintenance phase. And which phase consumes the maximum effort? And we've seen that it consumes almost 60% of the effort, and that phase is your maintenance phase. And this there is a distinction of various phases which were combined to make a development phase. So development phases, in terms of development phases, the maximum effort is taken by the testing part. Now we have a question, fifth of this chapter in this book, which is draw a schematic diagram to represent the iterative waterfall model of software development. And deliverables also you can show, but let us see the diagram first. This is feasibility study followed by, and waterfall you have to show like this because water is flowing from a place where you're standing, which is at some certain height, to the ground. And ground we suggest it to be maintenance. So we start in feasibility study, and then requirement analysis and specification, then design, coding and testing, integration and system testing, finally the maintenance. So the feasibility study will give you feasibility report, requirement analysis and specification will give you SRS, that is software requirement specification document. Design would give you design document, will which may contain of high level design and low level design also. Coding and unit testing will give you documented code. The integration and system testing will give you test document. Finally, the maintenance. And this maintenance is, or this phase is going to consume all these documents as and when required. This is classical waterfall model, and if you are being told iterative, you can just draw a line and just give these arrows to all the starting and ending to all these different levels. Sixth question is, what are the important activities that are carried out during the feasibility study phase? So in feasibility study phase, what happens is, first we have to give or know the abstract problem definition, which is a rough description of the problem which only considers the important requirements and just ignoring the rest. So important requirements are being collected here. Then we formulate different solution strategies. Then we can have in the next phase the alternate solution strategies to examine their benefits and shortcomings, and finally determining whether it is technically feasible and technically also and economically also feasible, worthwhile to develop the product. Seventh question in the book is, give examples of software product developments for which the iterative waterfall model is not suitable. So iterative would not be good if the customer requirement is not well defined, right? But in this, it has been asked that what we have to give an example for which the iterative waterfall model is not suitable. So if you have an iterative waterfall model, then if your problem is well defined, you understand the problem, then you don't need to go to the iterative. That will be a classical waterfall model will do. It will do. So it depends entirely on the defining or well definedness of your problem, custom requirement, that you're going to use the waterfall model or your iterative waterfall model or classical waterfall model. The eighth question is discuss how the efforts spent in different phases of the iterative waterfall model are spread over time. This is an important question. So this is how we can really show it, represent it, that we have different phases, right from your requirement analysis and specification to your design, to your coding and testing, unit testing, then testing, and then you have maintenance. So the percentage of effort is like this. Least effort or very less effort is used or employed in requirement analysis and specification. Then around 15%, say, from this graph is given to design. Then around, say, 8% to the coding and testing. And then 20% is for testing. And finally, 60%, around 60% for the maintenance effort. But completion of this each phase typically requires relatively different amounts of effort to be put in by the requirement or development team. But this is a relative example of the efforts which may be taken. This is not very quantitative, quite subjective also. Then we have question like which life cycle model would you follow for the development of software for each of the following applications, and mention the reason behind your choice of particular life cycle model. So the A part of ninth question is a well understood data processing application. When you are aware of well understood data processing application, we will use iterative waterfall model. Why? Because this is the most cost effective model of development for well understood problem. Iterative waterfall model. B is a new software product that would connect computers through satellite communication. So it's a new software. Assume that your team has no previous experience in developing satellite communication software. So in this case, prototyping model may be followed, since the team has no previous experience in developing this kind of software. Then the question is, the C part is a software product that would function as the controller of telephone switching system. Here you can use prototyping model or iterative waterfall model. It is just based on the familiarity of the development team in developing this kind of systems. D is a new library automation software that would link various libraries in the city. Again, the same reasoning goes for prototype model and iterative model. And this again depends on the familiarity of the development team in developing these softwares or products. E is an extremely large software. It's quite large software that would provide, monitor and control cellular communication among its subscribers using a set of revolving satellites. So, in this, we'll choose spiral or evolutionary model. Why? Because these two are used when the software is extremely large. Why? Because once we talk about large, we have to also see that whether the team is familiar with these similar products or not. So that is why we have introduced spiral model and evolutionary model here. F is a new text editor. Then again, prototype and iterative. Again, familiarity, context will come. A compiler of a new language. Same, prototyping and iterative waterfall model. An object-oriented software development effort. For that, evolutionary is good because the objects make up well-defined components of a product, and this evolutionary model leads to more manageable and reliable product. Graphical user interface, part of large software product. For this, you can use prototyping model since the user would see it and would really like to add or change various user interface components. Then we have, what is a prototype? This question is, what is a prototype? Under what circumstances is it beneficial to construct a prototype? And does construction of a prototype always increase the overall cost of software development? Let us answer it one by one. Actually, the prototype is a working model. It's not an actual software, but it is a working model of a system. Why it is beneficial to construct a prototype? When the requirements are not well defined and there are technical risks in the development. And the second part is, we'll answer as no, because when you throw away prototype, it does not always increase the cost of development. Since the cost of the construction of a prototype is more than the offset by the rework, means the effort you're going to put to rework if you make a software, total complete software, and if you are told to change it, then what you're going to do? You will be putting a lot of effort and money there. Question 11 is, what are the major advantages of first constructing a working prototype before developing the actual product? There are various advantages. First, you can eliminate the ambiguities in user requirement, and you can also get rid of various technical risks. The experience you attain in developing a prototype, this helps to develop your product quite better when you are doing actual implementation. 12th is, explain how a software development effort is initiated and finally terminated in the spiral model. As we have learned a lot about spiral model in our discussion of the chapter, we can easily summarize that during each phase, which is the loop of the spiral, some goals are identified. And the risk to this goal is then eliminated through the construction of a prototype, and finally the goal is implemented. And the product development team the product development team says that the product development is complete when the risk in all the goals have been resolved and all goals are now being implemented. Then explain why the spiral life cycle model is considered to be a meta model. Why it is a meta model? Because it contains various models, the aspects and the goodness of various models. So it is a meta model because it is subsume all other models. A single loop spiral model is actually a waterfall model. And the spiral model uses a prototyping approach by first building a prototype before the actual product commencement can go on. And the spiral model is supporting evolutionary model also, because you have iterations along the spiral, which can be considered as evolutionary levels through which the complete system is built. And this is going to enable the developer to understand and resolve the risk at each evolutionary level. This is called iteration along this spiral. And the spiral model uses prototyping as a risk reduction mechanism and also retains the systematic stepwise approach of waterfall model. So spiral model can be considered as an amalgamation of, or the extraction and feeding of the goodness or benefits of your evolutionary model, but with a feedback from your prototype model and the iterative waterfall model. Then the 14th question is, explain the suitable examples. The types of software development which the spiral model is suitable. Is the number of loops of the spiral fixed for different development projects? And if not, explain how the number of loops in the spiral is determined. This is a very good question. So first part is, spiral model is used or suitable or employed when you have a very large software. You have a very huge software development efforts, and that may be subjected to quite many risks. The second part is, no, the number of loops are not fixed. You cannot fix, it depends on your software to software. So the loops in this spirals That are determined based on the number of risks that the project is susceptible to or subjected to. Now 15 is how are the risks associated with the project handled in the spiral model of software development. And we just suggested that we handle it by constructing the prototypes. 16th, compare the relative advantages of using the iterative waterfall model and the spiral model of software development. And also explain the help of a few suitable examples, the type of problems for which you would adopt the waterfall model of software development and the type of problems for which you would adopt the spiral model. And it's quite easy to answer. The iterative waterfall model is a simple model to follow and is very efficient for well understood problems. If you have a well understood problem, go for iterative, and if it isn't, there is risk involved, go for spiral model. 17. Explain using suitable examples the type of product development for which the evolutionary life cycle model is used, and the problems for which the spiral model is suitable. Evolutionary model is applied to develop the software or products that would require very large effort and also investment, and also when you would require a basic working system with some minimal feature which the customer required just now. He required that, okay, give me some working system so that I can just start my work, and then you can add it up. Let us take an example. When a product is to be developed quickly to capture the market, then you go in for evolutionary model. So we quickly release a first version, that is the basic working model, to the market, and then you try to add various features, and you can also charge for these features. 18th question is, state whether the following statements are true or false, and reasons also. The first is, the primary purpose of phase containment of errors is to develop an error-free product, and this is actually false. Why? Why this is false? Because the primary purpose of phase containment of errors is to reduce the cost of error correction that is going to come in later section, that is especially at the maintenance part. The B part is development of software product using the prototyping lifecycle model is always more expensive than development of the same product using the iterative waterfall model, since additional cost is incurred to construct a throwaway prototype. This is quite false. We have discussed it at a stretch in length that development of throwaway prototype does not always increase the cost of development, because the cost of construction of prototype is more than the offset of by the work or rework or the actual effort you are going to put when you are subjected to ill-defined user requirements and technical risks that you are going to uncover only at the maintenance phase or the phase or any other stage. So when you are making a prototype, you are aware of the risk problems, and you throw away, you have that experience that can be employed, that can be used in making a good software without ill requirements. Now you have a very good software which is maintained easily and cost effectively. Question 19 is, explain why it is not prudent to use the iterative waterfall model for developing very large software products. Now this is quite obvious. We have discussed this already. It is not a good idea. It is not a good idea to use iterative model. Maybe prudent, for very large product development efforts. As the development organization may not have many development personnel and resources, or the customer may not be able to pay upfront for the entire product. So how are you going to cope up with this? Large products are often subjected to more number of risks. So it is not prudent to use the iterative waterfall model for developing very large software products. Then, instead of having a one-time testing of software product at the end of its development, why are 3 different levels of testing? Unit testing, integration testing, and system testing necessary? What is the main purpose of each of these different levels of testing? Now, this has not been answered by Dr. Rajib, but I'll give you an answer about this. First of all, there are various levels of testing or various testings which are carried out while development of software. Unit testing is done for the module level or unit level. You have a program, you have a module, you have a function. You check for any error. Now, when you have actually achieved no error in a simple module or a function, then you are sure that this module is not, or this function is not containing any error. That is why you use unit testing. Then when you have performed unit testing in these various modules, you combine them. You combine them for integration, and then you check for the integration, and you test that integration of these modules is not giving any error. Then this is the testing which is required, integration testing of modules integrated. Then you have system testing. Now, once you have this module being tested in combination with integration testing, then you have a whole system. Whole system means there are resources, there are different hardwares that may be there, and your software has to run in different flavors of operating systems and different ranges of your hardware. For that, you do system testing. So this is the main purpose of each level of testing, and doing it for once in the end of software development will only give you errors at some point or at one testing, but the errors which may not be uncovered at final testing will be propagated into various other phases like maintenance phase, and then you have to rework and spend a lot of time and effort in doing this testing. 21 is, what do you understand by the term phase containment of errors? What is the phase containment of errors is important. Why? And how can phase containment of errors be achieved? This is a very important question. Let us answer them. The principle of phase containment of errors is the principle of detecting errors as close, as near to their points of introduction as possible, which is phase containment of errors. And the phase containment reduces the cost of correcting the errors. We have thorough reviews. You can contain the errors through thorough reviews, and there are various other methods, but right now this answer would suffice. Coming to question number 22, irrespective of whichever life cycle model is followed by a software development, product development, why is it necessary for the final documents to describe the product as if it were developed using the classical waterfall model? This is an important question, because ultimately you describe or you make the documents with respect to or in accordance with the classical waterfall model only, but you are developing it with some other life cycle model, adopting some other life cycle model. The answer is the final document is in the form of classical waterfall model, because the comprehension of system documents becomes quite easy. Let us take this metaphor of mathematical theorem proving. A mathematician presents a proof as a single chain of deductions, even though the proof might have come from convoluted set of partial attempts, blind alleys and backtracks. Right? When I try to solve a question, or please understand that, or please assume that you are solving a question, a mathematical question. When you saw that in the rough part you write something on the rough paper, then finally when you are sure that this is how I'm going to devise it, I'm going to write the answer, write in a proper manner, in a stepwise manner, in a comprehensible manner. So you don't just leave those rough work. This is the example, and this is why this is done. 23. Suppose you plan to undertake the development of a product presets with a large number of technical as well as customer related risks. So you have various risks. Which life cycle model would you adopt? Give the reasonings behind your answer. And this is quite obvious that you're going to use a spiral model or prototyping model, because it depends on the size as well as the risk, and these two models deal with the risk. Actually, spiral model use this prototyping concept only for risk mitigation. 24th is suggest a suitable lifecycle model for a software project which your organization has undertaken on behalf of certain customers who is likely to change his requirements frequently, and give the reasons behind your answer. So the question says that these requirements are not well defined, they are fixed. So you'll use a prototype model. The prototype can be changed until the customer freezes his requirement. He says, okay, now you have given me the product which I would want, after a lot of prototyping, and then the development can be actually started. So this was the chapter we have taken from Dr. Rajib Mal Solutions.